The basic form of the hyperbola is y equals 1 over x. In this formula, we can see that x will never equal to 0 because 1 over 0 is undefined. We should also see that y will never equal to 0 because there's no value of x where 1 over x will equal to 0. These two values, x equal to 0 and y equals to 0, are known as the asymptotes, the vertical asymptote and the horizontal asymptotes. And we'll see them on this graph here. The dotted line here is y equals to 1 over x. The graph or the y values, as x gets closer and closer to 0, these y values will get larger and larger and larger, but they will never equal to 0. So this graph never equals or never touches the y-axis here. And same with the x values. As x gets larger and larger and larger, y gets smaller and smaller and smaller. It approaches but never touches the x-axis. So these two values, the y-axis, which is the equation x equal to 0, and the x-axis, y equal to 0, are our vertical and our horizontal asymptotes. This dot here is the point 1, 1, and we'll see what happens to this point as we change the graphs. The power form of the function is y equals a over x minus b plus c. This power form provides dilations and translations of the graph of the hyperbola. Let's see what happens as I change a. A has the effect of changing the shape, so it makes it fatter and thinner in layman's terms. We'll also see what happens to this point 1, 1. In the original graph, x equal to 1 gives us y equal to 1 over 1, which is 1. In the power form, we have y equals a over x minus b. At the moment, b is 0, so a over x. Let's see what happens to this point as I change the value of a. So now a equals 2. In the original graph, we had y is 1 over 1, which is 1. In this graph, we have y equals 2 over 1, which is 2. So changing the value of a has the effect of magnifying these points or dilating these points along the y-axis. As I increase the value of a, this point just moves further and further along the y-axis. As a decreases, this point comes back down, and as a becomes a value, a fractional value between 0 and 1, you'll notice that the graph gets a lot narrower, a lot closer to the axes here, to the origin here. It will never actually reach the origin. At this point in time, we have x equal to 1, and y will be 0.3 on 1, which is obviously 0.3. So turning off the point, let's just move a back to 1. What we will notice though is as a becomes negative, the graph flips upside down. It's mirrored across the x-axis. And should also notice that moving the value of a does not change the value of our asymptotes. The asymptotes remain steady. So let's see what happens as I change b. As I move the value of b, like with most of our other power functions, the graph will be moved or translated left and right along the axes here. So it's moving left and right. We'll also notice that our asymptote, our vertical asymptote, is moving along with the graph. Now, why is that? Let's have b equal to 4 a minute. Let's turn off all the other distractions. Y is the vertical asymptote now at the value x minus 4. Let's look for a minute at the function y equals 1 over x minus 4. It should be obvious from this equation here that if x is equal to 4, then we have 1 over 0 once again, which is undefined. So this is why the vertical asymptote moves along with the value of b, because x on this bottom line, if x is ever equal to b, then we have 1 over 0, which is again undefined. Let's move that back to, let's set b back to 0. Let's now have a look at c. As with all of our other power functions, moving c or changing the value of c simply translates the graph up and down. Let's review our function again. The power form y equals a over x minus b plus c. This implies that x cannot equal to b because we would have 1 over or a value over 0, and y will never equal to c because this value here can never be 0, therefore we can never get exactly equal to c. Our vertical asymptote is at the line x equals b. Our horizontal asymptote is the value or the line y equals to c. The domain of this function is all of our real values except for the value x equal to b, and our range is all of the real values except for the value y equals to c.